to talk about the concept which is called abstract data type. We will just start it here, and then next time we will talk with two examples. We will see what do I mean by that. Abstract data types. So that is like abstraction. That's a dictionary definition. Is the process of removing characteristics from a real life entity in such a way that the remaining things represent the essence of this entity, right? I abstract something complex, something messy, something detailed into a pure kind of concept of it. In computer science, abstraction works by creating abstract data type of a real life entity. In art, in all different like cultures and so on, abstraction might mean something else. We see that, for example, this symbol from Japan represents many things at once. See, that's not how it works in computer science. See, in computer science, abstraction always represents something very, very concrete in only one of it. So abstraction is a process of extracting only essential properties from a real life entity. In computer science, that will be like this. We take a real life entity and convert it into this, describe it using storage and operations. So simple, so like boring, right? That's not art and whatever. There is an art in it anyways. Okay, so abstract data type is the result of the process of abstraction. So we look at something like, let's say, okay, I need to keep track of students in my class. How can I abstract this task? I will create abstract data type called student list. I will store students in the array, and then I will have the following operations. Add student, remove student, and so on. That is kind of example of abstraction in computer science, right? So to create an abstract data type, we need to specify what data we want to store and which operations we want it to support. So abstract data type is the definition of data plus the operations on these data. Okay. So abstract data type is absolutely language agnostic concept. It's a concept. Different languages will support ADT in different ways. In Java, we use class or interface or abstract class in order to describe an abstraction. Abstract data type defines specification of a data type. Specification, what needs to be stored, what operations should be supported. It's like an idea of what we want to have in order to solve some real life problem. So each abstract data type has precisely one specification. It might have more than one implementations. We can use different data structures, array or linked list, to implement particular type, or we can use different algorithms. Okay, specification declares public variables and methods, whatever is public. Implementation implements these methods in the most efficient way. Okay, so here is an example. Let's say this is an abstraction. I want to create abstract data type, big integer, where I can store integers of arbitrary lengths, right? You know, the integers have limit in the computer. But here I want to somehow come up with an idea that I can store integers of any size, any number of digits, any number of bytes, right? For this, I need to do something inside of my program, right? So there is this simple implementation, for example, it's called big integer in Java. You as a user, as a person who trusts developers of Java, would use this class in order to store very big integers. Not necessarily you would know how the storage is implemented inside this class. Not necessarily you would know how the operations are implemented inside this class. All you need to know is the specification and what it can do for you. See, in order to use big integers, you only need to know what they are, what big integers you have in mind, and what the operations do. You don't even need to know how it is stored there. Is it an array? Is it a linked list? Is it something else? You know, how do we store all these digits, right? How do we allow it to be so big, right? So we do not need to know what algorithm it is, because we always can have like different implementations of the same exact idea. Tomorrow you can sit and implement your own big integer class. As a matter of fact, there will be a nice assignment. Maybe I should do it next time. Okay, so in this course, we will write our own implementations for some abstract data types. By the way, you already not writing, I already like gave you one of them, which is called bug or multiset. See, the idea of bug is abstract data type, is some storage of things which we can throw things into. The order doesn't matter, and like how they are there. Like I can add things and remove things. That's all it is. The storage, the idea of like big bug, which you go to buy things into the store, right? So this is an idea, abstract data type, right? So then when and it can be implemented in this particular instance that is given in your assignment, it's implemented using an array, but it could be implemented using linked list. The idea itself wouldn't change from that. You see, the implementation would change, the code will change. So principle, when implementing abstract data type, we must keep the specification and the implementation completely disjoint. When I describe to you a new data type, abstract data type, I do not talk about how you want to implement it. It's already up to you. The implementation details should be also hidden from the users of the abstract data type. Nobody needs to know how you implemented it, right? Then we will see how it works, how fast does it work. So, okay, in Java, we often use interface to specify an idea of the desired type, because the interface is the most abstract concept in Java, right? It doesn't contain any concrete implementations. It doesn't contain any concrete structures inside it. It only specifies what I want. I want to be able to add, to remove, and like delete, or remove is delete, sorry. However, the list of public methods of any Java class can also be treated as a specification. It does not have that. If you read your book, it says interface is an abstract data type, implementation is a class. That's not correct. That's some sort of misunderstanding, right? Any class can be treated as abstract data type. I can say, here is my class, here are its public methods. I defined by that some idea. Understand? Idea which I want, like to implement. And then inside those methods, you implement it. That's going to be implementation, right? So that was the part of abstract data type, which might sound to you really kind of like fishy, not concrete. But now we're going to look at two abstract data types, and this idea will become pretty clear, I hope, after these two other data types.